The Headless Professor presents operational definitions. Our objective in dealing with science is to look at its fundamental logic. The purpose of science is to develop a causal model of external reality. We want to use this model to try to understand the cause and effect relationship between different variables. We then use this causal model to predict what is going to happen next, what our present causes will result in as future effects. We also want to use this model to control those future events by developing a technology. So the logic of science must identify specific, measurable events and put them in some kind of causal sequence. In order to do this, we've got to look at each variable in terms of an operational definition. The operational definition of a variable is exactly how we're going to measure that variable, or manipulate it, control it, or randomize it. If we cannot operationalize a given variable, it cannot be studied empirically, and science cannot figure out any relationship of this variable. Whenever we are talking about philosophy, the synthetic descriptive statements require that every variable be anchored to something that's empirically measurable, not necessarily visible, but observable in the sense of being objectively measurable. Theology is not empirical. Any claims about God, salvation, or the afterlife cannot be resolved with any kind of empirical measurement, telescopes, microscopes, or DNA labs. So let's get back to the point about trying to operationalize the variables we study in science. There's only 4 ways that a variable can be operationalized: through measurement, manipulation, control, which makes a variable a constant, or to assume some kind of randomization. Now, the way we measure variables is very important. All dependent variables must be measured. We can also measure some independent variables, but we can also deal with independent variables in other ways as well. One simple way of measuring any variable is by classification, taking each participant in our research, each case, and classifying as a male or a female if the variable were to be gender. Perhaps we can classify each subject as a before or an after, experimental condition or control condition in an experiment, pass or fail on a test, or in the case of a consumer trying to select a product, choice A, choice B, or choice C. Another approach to measurement, which involves what are known as ordinal scales. Here we try to classify each subject into a given level in which there is some kind of intrinsic ordering, such as excellent, good, fair, or poor. This approach would be useful in measuring the dependent variable of performance. A Likert scale is very useful in measuring the dependent variables of attitudes. Here we express a given attitude and ask for the subject's level of agreement. Totally agree, mostly agree, neutral or don't know, mostly disagree, or totally disagree. We can also give the subject a prediction and ask for that subject's evaluation of the truth or likelihood of that prediction. Definitely, probably, possibly, or no way. Another ordinal scale would be to ask how well a given adjective or characteristic pertains to a given subject. Extremely, very, somewhat, slightly, or not at all. Another ordinal approach would be a frequency scale, where we ask a person how often something occurs. Always, usually, sometimes, rarely, or never. Perhaps the most precise way in which variables can be measured is by an enumeration, an actual numerical value, such as age 59, to describe a person's age, or a specific score on a test like 76 out of 100. The more measurement can be precise, the better the measurement. Variables can also be manipulated. In other words, this is when we intentionally make subjects different on a given independent variable. And this can be done in various ways. Perhaps the best one is to randomly assign the subjects in our sample to two different groups and then treat those groups differently. This manipulation of an independent variable is the essential feature of an experiment. If there is no manipulation of an independent variable, don't call the research an experiment. Variables can also be held constant by controlling them. One of the easiest ways of doing this would be by exclusive sampling. If I only selected students from an all-women's college, the variable of gender would be constant. They're all women. Another approach would be to have proportionate assignment to two different groups, so that a given variable, such as gender, would not differ between the two groups. Variables can also be randomized. If you have a very large sample, you can assume that many of the background variables will not differ significantly if our randomized assignment methods work well. So the success of randomization depends not only on having a large sample to start with, but really random techniques in our group assignment. Randomization can never fully be attained or verified. It can only be assumed. But the larger the sample and the better our randomization techniques, the safer we are in making that assumption. In good scientific research, it is very clear to the observer and the reader of that research how each and every variable was dealt with, how it was measured, manipulated, controlled, or randomized. Thank you for watching this latest in the Headless Professor video series.
Create your very own video podcast from PowerPoint. Log on to authorstream.com. It's absolutely free.